You know, every time we fly, we're trusting a whole bunch of really complex systems to work perfectly. But one of the most critical safety checks, it's something you'll probably never even see. It's this delicate, super high-stakes calculation that has to happen before every single flight. Today, we're diving into aircraft mass and balance.
Okay, so let me just start with a really stark example to show you how serious this is. Picture this. It's 2004. A Boeing 747 is on the runway in Halifax. Here's the kicker, though. They accidentally used the takeoff weight data from their last flight, which was way, way lighter. So the pilots, they just didn't have the right speeds calculated for their actual, much heavier plane. And the result? It was catastrophic. They ran out of runway, hit an earth bank, and the aircraft was completely destroyed. That right there is what happens when the math is wrong.
And that incident, it just perfectly tees up what we're talking about today. See, mass and balance isn't just about asking, how heavy is the plane? No. The real question is, where is all that weight? Getting that distribution right isn't just, a good idea or a recommendation. It is an absolutely fundamental requirement for a safe, controllable flight, period.
I mean, it kind of sounds unbelievable, right? How can something as simple as where the bags are loaded or where people are sitting have such a huge impact on this multi-ton, incredible piece of engineering? But trust me, it absolutely does. And to really get why, we need to dig into a core principle of physics.
Okay, so the entire science of aircraft balance, it really just revolves around one single crucial concept, the center of gravity, or as you'll hear pilots and engineers call it, the CG. So what is that exactly? Well, to put it simply, the CG is the one single point where you can imagine all the aircraft's mass being concentrated. It's the theoretical balance point for the entire plane. Here's a cool way to think about it. Imagine you could somehow balance a 200-ton airliner on the tip of a giant finger. That one single, incredibly precise point where it wouldn't tip forward and it wouldn't tip backward. That is the center of gravity. But, and this is a big but, here's the real challenge. An aircraft's center of gravity isn't some fixed, static point. Nope, it's a moving target. And managing that movement is absolutely key to everything. Just think about it for a second. Every single passenger that walks on and finds their seat, every bag that gets loaded into the cargo hold, heck, every single gallon of fuel that gets burned off during the flight, it all shifts that balance point. The CG is constantly moving, forward, backward, and the flight crew has to account for every little bit of it. See, for every single phase of the flight, we're talking takeoff, the cruise, and all the way to landing, that center of gravity has to stay within this really narrow, predefined safe zone. If it moves outside of those limits, even by a little bit, the aircraft can become dangerously unstable or just incredibly difficult to control. So, the big question is, what happens if the CG does go outside that safe zone? Well, it can basically go wrong in two ways. You can be too far forward, or you can be too far back. And let me tell you, both are dangerous, but for very different reasons. Okay, so if the CG is too far forward, the plane is nose heavy. Now you might think stable is a good thing, but in this case, it's too stable. It's so stable that it becomes really hard for the pilot to pull the nose up for takeoff or for landing. It's like trying to lift a wheelbarrow when all the heavy stuff is right at the very front. Then you've got the opposite problem, a tail-heavy plane, where the CG is too far back. This is a whole other kind of dangerous. It makes the aircraft unstable, and it can cause it to pitch up way too sharply on takeoff, which could easily lead to a total loss of control. The aviation manuals, they state it so plainly. They say a tail-heavy plane is less stable. And yeah, it might technically be a little more efficient during the cruise, but the trade-off is this massive loss of safety and control. It is a risk that is just never, ever worth taking. So, if the stakes are this high, how on earth do airlines and flight crews solve this puzzle, not just once, but for thousands and thousands of flights every single day? Well, it all comes down to a really systematic process of calculation. They basically build it up in layers. First, you start with the basic empty mass. That's just the plane itself, the structure, the engines, all the fixed stuff. Then you add the operational items, so the crew, their bags, all the catering. That gives you the dry operating mass, or DOM. Next up is what they call the traffic load. And hey, that's you and me and all our luggage. When you add that, you get this zero fuel mass. And then, the very last step, you add all that fuel, sometimes thousands and thousands of pounds of it, to get the final takeoff mass. And here's the really important part. It's not just about adding up the weights. Each one of those components has a specific mass, sure, but it also has a specific location. And that location is what really affects the final center of gravity.
Okay, so let's zoom back out and bring this all together. What does this all mean for us, for the safety of flying today?
Well, this whole process, all the weighing, the calculating, the incredibly careful loading, it's truly one of the most vital, yet almost completely invisible pillars of modern aviation safety. It's all this meticulous behind-the-scenes work that guarantees the pilot has a stable, predictable, and controllable aircraft from the moment they push back from the gate to the second the wheels touch down.
You know, once you understand this stuff, it totally changes how you see an airport. That ground crew you see loading the bags, they aren't just chucking them into the nearest open space. No way. They're following a super precise loading plan. And that fuel truck? The fuel isn't just a number, a quantity to fill up the tank. Its weight and where it's stored in the wings are the final, absolutely critical pieces of this massive puzzle.
So, next time you board a plane and you're sitting there looking out the window as everything's being prepared for flight, what are you going to notice now? You'll know you're not just watching bags being loaded. You're actually watching that delicate, invisible balancing act happen in real time, the very one that makes your entire flight safe and possible.